In this tutorial, we'll look at how we're going to transmit an integer value from processing to Arduino using the serial connection between the two, and then have Arduino echo that back. That will be our first step in just being able to ensure that we're transmitting values back and forth correctly. The second step will then be to add the control of the servo motor to that using that integer value. All right. So I've got a processing sketch, a blank sketch here, right? Or I've got the purpose listed of what we're doing and what we're going to do now to implement the serial port and processing. We need to import the libraries. So all of the processing serial libraries. And then let's create we can comment this later. Let's create a serial object. All right, it's of type serial. We'll refer to this as my port or the port. How about S port? All right. And in order to work with serial port, go ahead and write the setup function. We'll open up the port. First, let's just create a window of size 480 by 340. All right, any size. All right, we're going to end up displaying some information here, so we'll create that now. All right. What we want to do is we're going to go ahead and list in the console window down here all of the available serial ports. So we're going to say list the available serial ports. This helps in case you don't make a connection, right? You can see a list of all your ports available and maybe alter the sketch for the connection you need to make. We're going to call the print array function, and we're going to pass to it then serial.list, right? And that will provide us a list of all the serial ports that are available in the operating system, right? It's simply a list is just an array of strings, and that's what we're calling print array here. All right, now we need to open the port. Open the port. Right. So now we've called our object, our variable S port. In Java, we say new. It's of type serial. We're calling the serial constructor. We have to pass it to this pointer. And once again, we're now going to list all of the ports here. And then by default, we're going to say this list will have at least, well, hopefully one port in it. But we're going to say take the port listed at index 0, right, and open that at a baud rate of 9600. Right. Open the port connected to the Arduino at a baud rate that's what that statement does, and let me bring that on the screen, back on the screen for you. All right, so we follow these steps in processing to open the serial port. All right, and then because I'm using an older, oh well, I shouldn't say an older, it's a couple of years old, an off-brand Arduino Mega that actually seems to require a delay of 2 seconds before the serial port starts working. So I'm going to say delay of 2 seconds needed when communicating with some Arduino Mega 2560 boards. And a delay isn't bad. All right. This is the setup function, and this is the end of setup. All right, this is what, oh, and I didn't call it delay. Delay, milliseconds 2000 is 2 seconds. All right, and there's our setup function. Right now in void, well, if we draw something, Well, we need the draw function. So if I set the background to 0, all right, we'll do that. And then what we want to do is we want to go ahead and eventually write some text there. Right? Well, the text we'll write will be based on the information that we're going to receive back from the Arduino. But first we need to send information to the Arduino. Right? One way we could do that is we could maintain a count. Right? If I make some variable, call it count, initialize it to 0. All right. What we could do here is we could then, whenever we want to write, we call then, well, our variable is called sport.write, and I could write that count. All right, so that's going to serial transmit. Right. Serial transmission. Right, that's what that write function does. And then we could initialize the count and perhaps put in, let's do that a couple times a second. And so we're taking care of our serial transmission here. We'll probably put this in its own function in a little bit, but this should go ahead and transmit it then, right? And we'll connect an Arduino on the other end of the line. Now, what I'd like to do is once we transmit this to Arduino, we can't open the serial monitor to see what the Arduino is seeing. What I'm going to do is I'm going to have the Arduino program, when we write it, echo the data back. It's going to receive this data, it's going to echo it back. So we want to then be able to read the data that comes in, that we receive on the serial line. There's different ways to do it. In this example, we'll use the serial event function. It has to be coded just like this, serial. We'll call our port P here. All right. And we're going to store this. We're going to call then a function called readString. We'll just read the information that comes back as a string data type. In order to do that, let's make a variable called inString. So Java has the string type. inString will be the name of our variable. All right. And so we want to assign the string we read to inString. Right. All right. And then we could print this out down here in the console. So if I said print ln, I print out the contents of inString. Right. If we do this, now, since I haven't initialized string to anything, we may see that string is null when we do this. Right, let's make that window a little bigger, but we're going to need the Arduino program to do this as well. Let's save this. All right. Trying to figure out why that came up. My sketch has been modified externally. All right, not quite sure why that popped up. Let's see what happens. All right, let's start an Arduino program then. I'm going to start up Arduino, grab a new sketch. What we want to do here on the Arduino portion of that, all right, let's minimize this for a second so it won't be distracting. All right, we want to then read in the serial data. Okay. So the purpose is All right. The serial connection to read integer value and then echo back the value received to the sender, right? All right, so in order to do that and set up to use the serial port in Arduino, right, we just say serial.begin, right, to enable the hardware. We want to put it at the same baud rate as our other program. And let's create a variable called byte received in the loop now. All right, different ways we could receive it. There's Arduino has a serial event function. Let's just try if serial.available. Remember, this function tells you whether any bytes have been received, right? If there's, so we're going to check to see if it's greater than 0. If it is, that means at least one byte has been received and we can read it. Well, then what we'll store in byte received in this variable, what we'll assign there, we'll call serial.read, right? Serial.read reads in one byte at a time, right? If no bytes received, it returns a -1, which is why we only want to call this function if there's something available to read. Right. And once we do that, once we read that, let's just go ahead and say serial.print, and then we can just print the byte received back. So that's how we transmit it back. All right. Now, we'll say echo back byte read. So we'll send that back then to processing when we connect the two. Now what I'd like to do is, instead of print, I'd like to make this print ln. So it's going to echo back not only the byte, but the new line character as well. And we're going to need to adjust our processing sketch just a little bit for that, right? Because what I didn't put in here is a buffer until command. Right? We opened up our serial port, but we want to actually then add some code that says buffer until. All right. So here, we're going to add the code then, sport.buffer until, right, this is in the serial library. And then we're going to say LF line feed, and let's just create that variable as well, int LF equals 10. This is the line feed. So that's the ASCII line feed character value. Right. And what buffer until says, right, is store information until you receive the new line character. So store all bytes received, right, by the serial port, including the line feed character, right? Trigger a serial event. When the line feed character is received. All right. So what that does is, let's talk about the way this is going to work now. At the draw function, it's going to go through, it's going to transmit this count. We're going to increment the count, and then we're going to delay about a half a second. When the Arduino program receives this, right, receives this byte, serial.available will be greater than 0. It'll indicate a byte's been received. The Arduino program will read this, and then it will write it back. It'll write back the byte received in the new line character. So as the draw function runs, when it gets down here, before it goes back and loops back up, so remember this is an infinite loop, it checks to see if there are any events. Right? There's mouse events, keyboard events, serial events. Well, in this case, right, there will be a serial event when it's received something. When it's received the line feed character, it triggers a serial event. So before it loops back up, it automatically goes to the code we have written in the serial event function. And in this case, it'll read in the string and it'll print out the string down here in the console window. Right? And that's what I'm hoping happens. Right. Now what I want to do is I'm going to go ahead and upload this to my Arduino. And video Arduino. Serial. All right, so I just save that with the name of the example from the video, and we'll wait while this uploads. All right, now if I just want to confirm the serial port's enabled, I can open up the serial monitor. Notice we're not getting any output, but if I were to just type in the character 7, right, we get the ASCII 55. All right, so this is receiving something and it's transmitting. All right. So now, let's see, we're on COM4. Let's run processing. I think COM4 will be the first thing in the list here. All right, notice COM4 was the first thing in the list. We got our black window, our empty window coming up. So it went ahead and opened up the COM port because I was at COM4, 0. Notice now we've got the string number changing, so the count that we're sending here. So this count, we're incrementing. Notice in the console window, it's going up by 1, so we're writing that information. When Arduino echoes it back, we're grabbing it here and writing it in the console window. Good, so we've been able to transmit and receive. Sometimes that's a difficult thing to get running. All right. And we always go back to examples that we've had that before that have successfully done this and take that code and rework it for whatever we need. Right, now let's just maybe change this a little bit here in terms of, instead of just writing things in the console window, let's just go ahead and show the text in the window. And so here, right, I'll just call the text command. I don't really need a comment for that. Over comment this program. So we're going to then, the text command is going to display things in the window. So we'll display this string received, and then we'll add on, we'll append to that in string. So the string library, this isn't doing addition, this is saying append these characters in this string to the end of received, and then print that at x equals 10, y equals 50 in the window. Right, so now if we run this, right, so there's the message received, and we can see the number going up 1 by 1 there. All right, oh, we added that. Now if we wanted to, we could add things about making the font bigger, things like that, right? Our main goal was to just be able to send and receive some information here. Now string starting out null, let's go ahead and give it some sort of known value here. So we're just going to initialize in string to a message called start state. That's it. Make that change, we pop this up. We can see that we had that message start state there until we started receiving numbers. All right, that'll let us know, right, when we start receiving numbers, other than just having the null there. All right, And what we'd like to know now is the number that we're transmitting, is that number then actually being received and treated as an integer value over here? Can we control the servo motor with it? Before we actually write some of these values to the servo motor, we probably need to change this here from just count. All right, because we're not placing a limit on count. And let's actually write a function now. Void, we're going to say send integer value. And all I'm going to do is take this code out of here and place it in here. And then call the function send integer value. Right? And if we run this again, all right, still working. Good. I didn't break it yet. All right. Now let's limit this value. All right, let's go to simulating our servo angle. So instead of count, right, maybe we'll just start calling this an angle, such as theta 1. All right. So our theta values before in our simulation program were floating point values. Let's just see how we deal with a floating point value. All right. Float, and we're going to then say, well, actually, let's just change count to a float so you can see then, since we can take a program that worked and see if we break it. And here it breaks it. Processing doesn't know how to transmit a floating point value. It can transmit an integer value, so what we're going to have to do is we're just going to have to typecast this to an integer value, which will simply truncate everything to the right of the decimal point, which makes sense, right? We want our angle to be an integer value in degrees in order for the servo motor to properly handle it. All right, so if we run that again, we can see, good, we're still getting our integer values. All right. And maybe instead of count now, let's start calling this theta 1. And let's have then our delta theta that we had before. And let's initialize those in here. Let's say initialize global variables. All right. So we'll say that theta 1 equals 0. Delta theta, let's set that equal to 1. And we'll say here that our units are degrees. And instead of count goes away. All right, we've got this theta 1. And what we want to do is, right, this is what's performing the transmission. Let's go ahead then and write a function that says update. We're going to update theta 1. All right. Similar to what we did in our simulation sketch. Right. Now in this case, right, we said theta 1 we wanted to assign to that theta 1 plus delta theta 1. And I should have called this delta theta 1 because when we have two angles, we'll need two different delta thetas. Well, if we do this much and just run it, all right, and we can see then that we're still sending out and receiving those numbers. Let's take a look at then the limits. Right? Just like with a simulation, we perform the simulation to limit the values to 180. All right, let's just go ahead between 180 and 0, including those endpoints. And we said if theta 1 is greater than or equal to 180, that was one of our conditions. All right. We then said, let's reverse the direction of angular velocity. And then because it's possible, depending, if our values of delta theta 1 aren't evenly divisible, if 180 divided by delta theta 1 isn't evenly divisible, leaving a remainder of 0, then this could potentially be past 180. And we said, let's just go ahead and correct theta 1 in that case. Plus equals delta theta 1. All right. And that now should give us our value between 0 and 180. And let's just start this, just initialize delta theta 1. Let's initialize that out at 175 so we don't have to go too far through the loop. And then maybe we'll just throw that no loop condition in here. So we can stop the code from transmitting and take a look at the value. Oh, so in this case, I never really actually got to 180, did I? Right. As soon as we got to 180, this was greater than or equal to 180. And we added that back. And 180 is a valid value. So there's a little flaw in my logic. So let's say instead of greater than or equal to, let's say it's greater than. And let's run that. Right, and now we can see it got up to 180. No loop had the draw loop execute one more time because of where we placed it. And we see that we're constrained at 180. Excellent. Now, our other condition was for theta 1 less than 0. Right, and that occurs then, right, when delta theta is coming back the other direction. So let's just set this equal to 5. Let's start delta theta at -1 to test. All right, we came down to 0 and we stayed at 0. It looks like we're now going to stay within our constraints when delta theta is 1. Let's test it like we did before. Say with -17. Let's start this at 90 and let's watch this work its way down. 73, 58, 39, 22, 5, and then we stay. All right. And that should equally work its way out. Let's just do a quick test then from 90 up to 180. All right, looks like we can constrain our values now within our range of 0 to 180, including the endpoints. And we'll hit the endpoints depending on our value of delta theta. All right. And now we have a mechanism for updating delta theta, right? Sending the integer value and then receiving it back. All right, and we won't watch all of that go by. What we want to do is I'm going to minimize this. All right, let's pop up that Arduino code. And, oh, sorry, there's a servo example. What I wanted to do is pop up the example we just wrote here. All right. And what we want to do is we want to add in that servo sketch. Right. We'd like to now start controlling a servo motor. Right? So let's control servo motor position using the value received. Right. The value received in the serial port. All right. So I'll say serially. All right. In order to do that, all right, for the servo motor, we need to include the servo library. All right, and you can look at that. All right, when you don't use these much, just go ahead and open up. There's that sketch file, examples, servo sweep. Right, when you open that up, this example then sweeps the servo motor from 0 to 180 and 180 back to 0. So if you don't remember then how to set up the code, you can always open up an example like this and look at the steps you have to perform. Right. And one of the things we need to do then, besides bringing in the servo libraries, we need to go ahead and create a variable for it. I'm going to call it servo. I'll call this servo1. You can call it anything you want. And now we need to attach. So servo1 dot attach, and I'll go ahead and attach it to pin 9, digital pin 9, like the example sketch. And maybe when this first starts up, I'll go ahead and set it to position 1. Meaning here, we've been using byte received as a as the angle we're receiving. Now let's create a variable then. Yeah, we'll use byte received. We don't really need to change that. But what I'd like to do is then let's delay maybe 1/10 of a second for things to get set up. And then let's servo1.write. Let's just write it to the 0 position, angle of 0. And then we have to delay a bit before we write to the servo port again, or sorry, the servo motor. You have to give the servo motor time for it to get to that position. Right. So we'll delay there. And what we want to do now is we'll just stay in this position until we get in a new value. When we get that new value in, let's just go ahead and servo1.write and write that new position, which is going to be byte received in this case. And don't forget we need to delay this here before we were to come back and write this. Well, before we were to come back and try to write to the servo motor again. From the processing side, only sending 2 times a second really shouldn't be a problem. All right. And what I'm going to have to do is wire up my servo motor. Yeah, I should probably tell this to upload. But I'm doing that. We'll wait for that. And what did I do? Oh, selected serial port's not available. That's because the processing sketch still has it. I need to stop that. Now let's upload. All right. So let me maybe turn the camera on here. See if you can see this servo motor. I can make this window pop up a little bit better. All right, so servo motor attached to Arduino. Right. Once I first started this sketch, it zeroed itself out. Right, my zero position just happens to be this right now. I could calibrate this better. All right, let's start then the processing sketch. And now I'm receiving this, but it doesn't seem to be, okay. There we go. Well, I can't hear that. That is just turning, right, 1 degree, twice a second. What I could do is over on this side, we could speed up our delay here. All right, let's start trying to send 10 a second. So let's restart this. All right, and that 1 degree at a time, right, is sweeping across. And so now we have a processing sketch that's transmitting information right over to the Arduino. The Arduino is grabbing it, controlling a servo motor angle. And so you can use this in your robot arm lab. Now my motor gets a little hung up around 180 and doesn't like to come back. If your motor's doing that, then you probably need to calibrate it in a way so that it, oh, sorry, it's because I didn't comment out the no loop. If your motor is misbehaving, you'll need to calibrate it to within the range of what it actually works. This will be right. All right, this is coming across. We'd like to see it get to 180 and come back to confirm that actually worked. And yeah, this motor's been worn a little bit. And by the time it got to around 140, it just sat and waited a bit. So if your servo motor's not working well, I've got some others that can get a newer one. But let's just then say this one works better within a range of 0 to 180. And it doesn't work very well down on the 0 end either. Notice it took a little while for it to respond. So this was happy till about 140 where I put it. Now it's coming back. So let's stop this, right? And so if you've got an older worn out motor, right, then this one didn't seem to be very happy. I think it was around 50. I'm going to change the code here to about 40. And that should increase the delta theta. This is holding at 0, and now I seem to have broken it. Oh, I broke it simply because, when I changed that to 40, my initial position was 0, and of course it was less than 40. And I believe I put it in an oscillatory state, which if I had my display going, I probably would have seen if I'd have paid a little more attention to what was down below. All right. Now, if I need to initialize theta then to 40, right, so it's not less than my starting condition, change my starting condition here to 40, and then maybe we'll change delta theta to 5 so we can see that moving across a little better, a little faster. Right. All right. So success finally, right? We've got this scanning across here. Now I've got an ultrasonic motor on here. You for your robot arm lab, of course, have a linkage. Right. I hope that didn't confuse you, right? We'll be doing this in another lab in the future, and I just happen to be working with this. All right, that's it for this tutorial. Good luck with your lab.